Welcome back. And here I wanted to little more explanation about basis, because which is very important, and spending time in basis is always worthy, because that is going to control the subject. I will explain very roughly and vaguely how these things are coming into the picture. Suppose, let's say I'm going to care about finite dimensional vector space. Okay, what is finite dimensional vector space? At least right now, at least there exists one spanning set S inside V such that the coordinate of S is finite. Then we call this a finite dimensional vector space. Okay, so later on we will see that if one such spanning set is finite, then we can obtain a basis. Then we will see all the bases as the same cardinality, and we will define that is a dimension, the number. Okay, after that we will see that is a only invariant. Given a number, everything is like specified natural number. Okay, now you will see like in the finite dimensional vector space, the set is very important. What is the set? One is the S is linearly independent. Second is S is spanning. That means we will later on prove that every vector belongs. So spanning means what? By the definition, every vector from V can be written as summation alpha I Vi, and Vi is from this S, alpha is from this F. This is the idea, and later on we will see about this more. And I'm saying that this uniquely written means what? Suppose, let's say Vi can be written as some beta I and Vi. Some of the beta i's are, let's say, I'm saying the finite dimensional line are ordered V1, Vn. Some of the beta I alpha i's can be 0, but I don't really care. Okay, this expression may be smaller, but I am making it n by putting 0 and Vi is extra Vs. Okay, now V minus V, that is equal to 0. That means alpha I Vi minus beta I Vi. That is nothing but vector space law. We can use Vi equals 0, but 0 vector equal to 0. That is saying that linearly independence says that alpha I equal to beta I, because alpha I minus beta I, each term should be 0, right? This is a scalar. The scalar must be 0. That is what we see about linearly independence. I'm using linearly independence. So every vector from V can be written as uniquely. This spanning plus uniqueness. This is very important. You see what is happening. Let's say in R2 at least, it's happening like I have a one vector here and I have another vector here. Then this vector controls this entire direction. This entire direction controlled by this vector. This entire direction controlled by together they control everything. The whole space they control. This is the idea. So you can think of like basis elements like board of directors. Let's say V1, Vn. These people are very important people, and field is the power. And using this power, this board of director controls one direction alone, and together every V belongs to V. Together they control everything. Okay, that is what happening here. Every vector can be written as something like something here, something here. So these vectors are very important, and this controls the directions, and they control everything together. That's the idea. It's like in a company, the field is a power source, and using the source they control every direction, and they are like harmonious in the sense that they don't overlap each other. That's what the linearly independence is very important. They don't overlap each other, they're working harmoniously. This is how it works, and this is why it's called basis. So basis basically controls entire vector space. To study about any other vector, you have to know about one basis, then that's enough. Okay, one basis and that's enough. That's how it's works. So basis are, it's very important concept. Okay, linear independentness and spanningness is both together gives that the uniqueness. So I wanted to know about the entire vector space, it's enough to know about the basis. And this is how we reduce to one by one. Even my vector space is infinite, doesn't matter, my basis is finite. Okay, so that's why we are dealing with finite dimensional vector space. So as long as we are in finite dimensional, we have a very nice things are going on. Next we will see about some basic properties.